Hello students. Today's topic is isomers. Now this is a very important chapter. Okay. Now what kind of isomers are we gonna see? That is isomerism is divided into two types. That is structural isomer one and one is stereoisomer. Now what is structural isomer? What is stereoisomer? That is structural isomer is based on the structure of the molecule or the organic compound, but stereoisomer is based on mainly on the um, optical or conformational or geometrical spin, or what we can say, the appearance of our organic compound. So let us see. In the structural isomers, there are different types, that is chain isomer, positional isomer, functional isomer, metabolism, and tautomerism. And in stereoisomer, there are also three types, that is geometrical isomer, optical isomer, and conformational isomer. Okay. First is our structural isomer. In structural isomer, what we are going to study first, that is our chain isomer. Now, what is chain isomer? That is their molecular formula will be same, but varies in properties of the chain. That means here we can see that is CH3, CH2, CH2, CH3. Its molecular formula is C5H12, but it is a normal chain. So that's why we write N pentane. Now, here as you can see, this is a iso chain, but the molecular formula is still C5H12. So we call it isopentane. Next is we are gonna see that the organic compound is like this, but its molecular formula is same again, that is C5H12. So we call this kind of structure neopentane. So as you can see, there are three types in the chain isomer, that is normal, iso, and neo. Now we are gonna see another example, that is uh, it varies due to the position of Br in the chain, as you can see. So it is a chain isomer. So as you can see, the main chain, that is our propane, is same, and it is also tribromide. So the molecular formula is not changing, but you can see the bromines are added to different carbons in and in different types also. So let us see the first, that is Br is added like this, 1 2 3 Br. If we give it a name, or so next is our 112. That means from this Br it has come to this carbon. Okay. So but the molecular formula is still same. Next is our 111 tribromo propane. That means this Br also came on this carbon. So now it is 111 tribromide propane. But there can be another variation, right? So what will be that? That is this bromine can also go on this carbon, right? So that is what happened here. That is 113 tribromide propane. So it is a chain isomer. Next is our positional isomer. What is positional isomer? That is position of a particular group, one group, that varies in the organic compound, but without changing its molecular formula. So that's how it creates positional isomer. So first is our C3H7OH. So as you can see, the first OH is added here on the first carbon, and in second case the OH is added on the second carbon, but the molecular formula is same for these two. So it is a positional isomer because it is the isomerism is based on the position of the OH. Next is C5H11NH2. So as you can see, here the NH3 is added to a second carbon, because we take the chain initiation from where the functional group is most closest. So next is we can see the NH2 is added on the first carbon, and here NH2 is added on the third carbon. but the molecular formula for these three is still same. So that's how it is a positional isomer. Next is functional group isomer. Now molecular formula is same but differs in the functional group. Now there are, I have shown you the particular type of what we can say compounds that show functional isomerism in between them. So first is our alcohol and ether. So as you can see, that CH3CH2OH and CH3OCH3 have the same molecular formula, but as you can see, it is a alcohol and it is a what, ether. So alcohol and ether show functional group isomerism in between them. And next is our aldehyde and ketone. So as you can see that in the first case there is aldehyde group, in the second case there is ketone group, but they have the same molecular formula, right? So aldehyde and ketone also show functional group isomerism. Next is carboxylic acid and ester. Okay, so as you can see that this group is a carboxylic acid group, C double OH, right? But see this group, that is C double OR. So it is a ester group. So ethanoic acid and methyl methanoate, so what, functional group isomer, right? Next is our metabolism. Now it is a very important what we can say isomer in structural isomerism, because it is shown by ether, amine and ester, three functional groups. So chain length varies at two sides of the functional group, but the molecular formula is same. But now ketone can also show that kind of isomerism, but in case of ketone we don't take it is as metamerism, we take it as positional isomerism. Okay, so let us see it for ether, that is CH3 CH2 CH2O CH3. So as you can see that on this side of the ether we have three chain length carbon and here is one chain length, but as you can see in the second case we have on the both side of the ether or O, that is two chain length carbon is present. So their molecular formula is same, but the chain length differs on the both sides. So here this kind of isomerism will be called metamerism. Next is a tautomer. So it happens between vinyl alcohol and ketones and called ketoenol tautomerism. Now this ketoenol tautomerism is explained evaluately in our tautomerism in just 5 minutes video. So if you haven't watched it, please go and watch it. The link is given in the description.
To learn difficult concept of physics, chemistry and biology within few minutes to crack NEET and JEE with fun, like, share and subscribe our new YouTube channel Shantu. You will get conceptual videos, highly effective notes, short tricks, mock tests and much more. Hope we shall meet there.